You should have met the idea of diffraction at GCSE. When water waves pass through a gap in a barrier, what happens to them will depend upon the size of the gap that they're passing through, and we usually demonstrate that using a ripple tank. Now, if the gap is much bigger than the wavelength of the waves, then they pass through more or less unchanged. So when lambda is much smaller than d, they're mostly unchanged. There's a bit of curving at the end, but not much. If the gap width is much smaller than the wavelength, then the wave will not pass through the gap, and then nothing happens on the other side. However, if the gap width is about the same as the wavelength, then the wave undergoes diffraction. The waves spread out on the other side. And what we generally find is that longer wavelengths diffract more. That's why when you're behind a door, you can hear the sound, but not the light, because the wavelength of sound is about the size of a door gap, about 1/3 of a metre. The wavelength of light is obviously much smaller, so the light doesn't pass through because the light's going in straight lines. So that's why you can hear round corners but not see round corners. However, light will undergo diffraction as long as the gap is small enough. If we shine a beam of light through a small gap, then this is the pattern that we'll see. We see a central bright patch, as you would expect, but then there's a dark ring, and then there's a slightly fainter, brighter area around that. We have the central maximum, which is, as I say, what you would expect when you shine light through a hole. We then have a minimum where there's no light, and then a subsidiary maximum. The amount the light spreads out depends upon the wavelength and the gap size. So, if we increase the wavelength, then the wave will spread out more. If we decrease the gap, then the wave will spread out less. We can calculate the angle of diffraction using this equation. We work out how far the wave has spread, and that gives us theta. Then sine theta is lambda over b. This has important consequences in resolution of images from telescopes and also from where you can hear two sounds. And we'll have a look at some questions on that in the worksheet.